All right. Is this working? I see that we have people already. If you joined us, yeah, say hi. Hi, Andrew. Oh, were you guys talking before I appeared? Is that even possible? I had no idea. Did I join the wrong room? Are you guys? Do we have some people here already? I know it's a few minutes early. Hi, Gayatri. How are you? So is it possible to join a live session before it starts? It seems like we had some people already join, or again, this is my second time doing YouTube live, so I don't know how it works. Hi Susan, hi Angel, hi Thomas. Oh, okay. I see. Andrew, what's your last name? Hey Nikandra. Hi Jeffrey. All right, so as usual, we'll wait till 6 p.m. Pacific daylight time, and then we'll start. So we'll just wait for everyone to wait in. All right, Scott. Oh, I see. Just have you wait. James. Hello. Callahan. Okay. Andrew, did I teach you? Your name sounds very familiar. I don't know if that's because you were one of the students that I've taught directly or something else. Yeah. Angel? Ah, okay. Awesome. Do I still play basketball? I'm really more into soccer now. Basketball, I used to play a lot when I was in high school and college, but then I don't enjoy it as much as I used to. I used to love it and I used to play a lot, but now soccer is a sport that I'm so bad that I can see my progression. Not like on a daily basis, but at least on a monthly basis, I'm getting a little bit better each day. So I'm really more into soccer now, but I'm pretty bad. But I still play basketball once in a while. A lot of you may know that I have a team in the Philippines, and um, people in the Philippines, a lot of them just love basketball, and they're really good. They play basketball with flip flops, sometimes even without flip flop, and they're so good. They're just so athletic. Well, at least the guys that I play with. So whenever I go to Philippines to meet with my team, I play basketball almost daily. But yeah, but over here I'm trying to get into soccer. Yeah. So Scott, okay, good. Um, Cannon, welcome to the class. Oh, I visited the Burbank location, Angel. Yeah. One thing that I kind of regret a little bit is not visiting all of the dojos that much. I mean, I should have, but with family and 5 kids, I really try to stay close to my family and kids. So I think I only travel some of the dojos only once in the entire 10 years of running coding dojo. So I feel a little bad, a little guilty about that. Um, but anyway, so Angel, I'm glad when I visited Burbank. I visited Burbank a little bit more because my older sister, and my older brother lives near LA. So I like going there, eat some Korean food and things like that. Yeah. Okay. Yeah. So Andrew, you attended Tulsa. Okay. Awesome. Yeah. Soccer, I don't think is that popular here, but it's a good sport. I love it. So yeah. Let's see. It seems like, is there a video here? Is it I see a wheel arrow, so I don't know if the video is having some issues. Okay, well, it is 6 p.m. Seattle time, so why don't we get started? And seems like there is some buffering going on too. Okay, do you know what? Before we start, why why don't I just make a visit upstairs and see if my kids are watching Netflix and tell them, hey, can you just turn off Netflix for an hour? Okay? I'll be right back. I should have done that before, but sorry about that. Just give me 1 minute to run upstairs, tell my kids to turn Netflix off, and I'll be right back, okay? Okay, I'm gonna do the meeting. Alright, so I am back. None of the kids are doing Netflix, so I don't know. Let's see if it does get better. It seems to be on and off. Okay? Alright, so let's see. Yeah, US soccer just not so popular. Ari, I'm glad. I guess it's a good thing that I'm a celebrity. Um, that's good. Yeah, it's a little bit lagging. Seems to be worse than yesterday. I think my area, around this time, a lot of people hop on the internet too, so that may play a factor. But let's see what happens. Right? Okay. Lacrosse. Oh, I miss sports so much. I wish I can just go and play sports, but with the COVID, it's hard everywhere. Okay, well, at least we can get our minds to exercise. So let's do some stuff. Okay, so what we're going to do is I'm gonna change the scene. I love whiteboard. Some of you may have heard the story. Um, if you have, just bear with me. But there was a profound experience I had when I went to graduate school. And at graduate school, my professor, they well, okay, there were a few things that really impressed me. So one was they didn't use PowerPoint. I always hated PowerPoint, but they used a blackboard with white chalk to teach, and I love that. And then there was another moment where at Caltech, my main professor, my advisor, he taught this subject that was really really complex. People spend semesters, studying this topic. So this morning he was supposed to do a lecture on this topic. So he comes in with chalk in his hand and he explains things and everything is making sense. It's very easy. And after half an hour, he said, "Okay, that's everything you need to know about thermodynamics because everything is derived from this what we discussed in this half an hour." And then there was this dead silence at the end of his statement because we're all thinking there's no way. There are books and books written about this topic, and there are all these advanced topics that are being taught about thermodynamics. You can't possibly say what we just covered in that 30 minutes, which was very easy to understand. He explained it very easy. You can't say that that's everything you need to know, that everything is derived from that. So we were just shocked, and we didn't believe him. And it took us weeks to find out that he was right. And that experience, for some reason, just had such a big impact in my life because, what seemed to be really, really complex, he was able to break it down very simply. And what people seemed to, all the complex stuff that people were explaining, it was actually them who didn't understand the simplicity behind the fundamental truth. So anyway, when I approach coding and other things, I always try to approach it that way too, that if I could explain it so easily that people walk away, then I wanted to emulate what my professor did back at Caltech. So anyway, I tried to find good analogies and examples because I'm trying to be like my professor, where in that 30 minutes he explained something so simply that made just a lot of sense to me. So anyway, I don't know if I share that with you guys, and I don't know if you were able to catch me because of the lag. So let's pause a little bit. How is the lag? Give me some feedback. I'm seeing the how fast is sending the data, and it's going up and down. I know it needs to send at about 2,500 kilobyte per second, and it's going sometimes at 1,000 and jumping up to 3,500 and so forth. So is this? I mean, how bad is the buffering, guys? Tell me, give me some feedback. And again, I'll wait a little bit for the comments to come in. Okay, so the audio is fine, but the video is very buggy. Okay. Let's see if that improves a little bit. Okay. Well, it's good that the audio is good. Listen to my audio more. And hopefully this will get a little bit better. All right. Okay, let's give this a try. So today what we're going to do is I did give you guys homework, and the homework was for you to watch the system design videos. Let me switch the screen a little bit. So you're supposed to watch some of the videos here, system design. Yeah, some of the videos are concepts that you already know, such as the IKEA store analogy. You know, that will bring some good memories for you, or bad memories of the dojo. All the hard work you put in. There are some additional things that wasn't covered in the bootcamp because I just created it last week for you guys. So those are new videos that I wanted you guys to watch, as that kind of gives a good picture. There was this analogy that I gave where I explained why there are so many technologies, and I came up with what I think is a smart analogy, but you guys tell me whether you like the analogy or not. And I use a game example. I like games. So Angel left a comment there that I really appreciated. So, you know, thank you, Angel, for leaving comment. But I only see one comment. What's happening, guys? Why are you not watching my videos and adding comments? I do apologize that this text is so unreadable. Yeah, when I designed it, I thought, oh, that looks awesome. Now I look at it, I'm like, what was I thinking when I designed this? So we'll change this. We have some bug with the YouTube video playing too, so sorry for some of those bugs. We'll get it addressed. But hey, I need to see more than one comment. So tomorrow when I wake up in the morning and check, I expect to see a lot more comments for each of these, because, you know, I did spend a lot of time thinking of you guys and, you know, trying to create a video so that I can help you prepare for interviews and other things. It may look like I didn't put in a lot of time. I did put in a lot of mental time to prepare. And then on Saturday, just last Saturday, I spent like 4 or 5 hours creating these videos, and I had a headache after that. So anyway, appreciate the pain that I went through. So the way you pay back is just add comments, just answer the questions, please, and that will make me feel better knowing that the hours I put in on that Saturday was worth it and it is helpful. Okay? So those are the things you need to do, and if you haven't done it, do it today. Do it today. Okay, do it tonight before you go to bed, or tomorrow morning when you wake up before the live class tomorrow. All right, you're also supposed to go through the advanced algorithms and data structures. Now this one, I'm going to constantly add things. You know, I told you that I'm going to be adding some more examples for dynamic programming. Today I had a really good idea. So I started writing an article. So I'll give you a sneak preview of the article here. And then, okay, I'm going to hide that because we're going to cover that during live class. So I'm going to post that over here because I came up with a really good, I think, section that I want to introduce before you do recursion. And again, it has to do with why are we studying these data structures, right? I cover some of the things on the big O notations, but why are we doing recursion with data structures? Why are we doing singly linked list, doubly linked list, stacks, queues, binary search tree, hash table? What's the point? So I think, you know, I kind of lacked some of that narrative in this module. So I'm going to add something here to kind of fill in the gap of the whys, right? Because a lot of these challenges focus on the how, like, okay, how would you do X, Y, Z? But again, how you do things doesn't really matter. That is, yeah, I mean, how you do it matters, but you also need to know why are we doing this, right? And I think, you know, right now it kind of lacked a little bit of the why. So I think either tonight or tomorrow, I'm going to add something and I'll put it on the Facebook group so that you can also know that I posted something new. So expect this to change, evolve a little bit. I did spend enormous amount of time creating each of the challenge, building test cases, and creating video solution for every single one. It was painful, but I think it's going to help you a lot because you can see my thought process. But I failed to explain why are we studying this. So again, today I started writing this down, and I think it came out pretty good. But we're gonna do a little bit of exercise today to get that started. Okay, so now I'm going to look at the comments and see if I missed anything. So yeah, the video smoothed out. That's good. Yeah, I see that it's stable. Awesome analogy. Style video games. Okay, great, Angel. That's good to hear. Netflix. And my kids are not doing Netflix. I don't know. Yeah, no idea. But it seems to be a little better, and then it went red again. So, yeah. All right. So Andrew, okay, good. Let's see. Audio is working, but video is very low frame rate, blocking. Audio is jumping. Okay. All right. All right. Sounds good. So let's commit that you're gonna watch the videos and add comments. I need comments. I need comment because right now it seems like only few people are watching the videos, and that's making me very sad. So please do the work and add comments. Okay. All right. Let's see. Is it dead? Is it? Oh yeah, internet is super bad. You know, one thing we could do it if it is. I'll do some troubleshooting to find out what's causing the internet issue. But if it is something that's outside of my control, maybe we'll just try a different time. It's going up and down. Yeah. Oh, consider changing Netflix password. Yeah. Well, they turned it off, so I think none of them are actually using Netflix. Okay, let's keep going again, and then see if it improves. Okay, so everyone, please do write comments and watch the videos. Okay, so let's go ahead and do the next one. The video that I made on advanced algorithm and data structure, the bagel notation, this came out pretty good. And I see that we got about six comments over here. Josie Bama, that's my brother. So it's really 5 of you guys. How many watched that video? If you did watch that video already, can you just add a comment so that I can kind of get a sense on how many already watched it? If not, I'll know that I need to explain a little bit more in depth. So go ahead and add a comment if you already watched that, and I'll start based on your feedback. Wow, it's either that. Okay, maybe the lag is really, really bad. So I got a response from Howard. Anyone else? Were you able to? That's good. Who was able to watch the big O notation video? Okay, the video seems to be kind of, up again now. Yeah. Yeah, I saw some people add comments. So, yeah, thank you for that. Okay, it seems like we got 42 people in the room, but I'm not getting enough comments. Maybe. Okay. Well, I'm just gonna continue. Let's see how this goes. Okay, so hopefully the video is a little bit better now. Okay, what did Claire say? Okay, all right, so let's do this. So today we're gonna, let's see if we want to do system design. But okay, some people watched it last night. Okay, so big O notation, I'll just give a brief overview. Do watch the video later on because that will be helpful. If I have a for loop from 1 to n, and if I have another for loop 1 to n, and if I'm doing some computation here, let me switch the scene so you can see it a little bit better. Computation. This is the end of the for loop and end of the for loop. This is not for any particular programming language. I'm just doing some pseudocoding. What's the order of operations over here on a big O notation? Okay, this would be O of n to the square because for how many computations I'm doing? Basically n square, right? Okay, so that's order of n square. And some of the sorting algorithms that you've done fall in the order of n square. Order of n square is super, super, super slow. As n gets large, you may be waiting minutes, hours. In the big O notation video, I talked about how on some you might be waiting months or years when n gets really, really big. You know, compared to an operation that's order of n, that could take, you know, minutes. Order of n to the third, when n gets really large, could be years. So you can tell that the difference between the orders of operation are huge. So whenever you're trying to write code, you want to make your code more efficient. So for example, if this is n, and this is the time it takes for the algorithm to complete, order of n would go linearly like this. Right? Order of log n will go at this order. Order of n log n is going to go like this. Order of n square goes like this. Order of n3 goes like this. Order of 1 basically just goes like this. All right, so you want to optimize things for this. So now I'm going to put you at the spot. Okay, you guys be ready because now I'm going to do what we did yesterday, which is you're going to answer some questions through the comments. Okay, so what we're going to do is I'm going to give a very high level overview of some of the data structures now. But when I'm doing this, here's a goal. You're supposed to tell me, as I explain the data structures, you need to think about this. Okay, search operation, insertion operation, deletion operation. For singly linked list, doubly linked list, stacks, queues, binary search tree, hash table. You're going to tell me for in singly linked list, doubly linked list, stacks, and queues all behave pretty much the same. Right, so we don't have to do that. Let's add another one. Let's add arrays. Okay, you're going to tell me in 10 to 15 minutes what the orders of operation for each of these are. Okay, you're going to give me 16 answers. So pull out a piece of paper, and I'm not going to have you answer right away. I'm going to remind you how these data structures work, but as I'm teaching some of these data structures, you will be like, oh yeah, that's how we do singly linked lists or doubly linked lists or stacks or queues or binary search or hash table arrays, right? But when so I'm gonna be giving some hints about some of these answers, but you're supposed to fill 4 times 3, so that's what? 12 answers. Okay, that's one of the things that I want you guys to walk away with. I want you guys to get some good intuition on which of these data structures are optimal for search, insertion, or deletion. Okay, if there's anyone here right now who can answer these 12 things on top of their head, good for you. Don't put your answer on the comment though, because we don't want to give it away for the other people. Okay, So is that clear? That's what you need to do. In 15 minutes or 15, 20 minutes, how long it takes, however long it takes, I'm going to have you guys each individually, every single one of you, there are 46 people in the live session, submit what's the order of operations for searching a value in a singly linked list, inserting, once the value has been found, what's the order of operation for inserting a value in a singly linked list? Once the value is found, order of operation for deleting. How about that for the arrays? How about that for the hash table? How about that for the binary search array? Is that clear? Okay, I'm going to assume that's clear. That's what I need you to do. So turn on your active mode. Don't just, sit back and like, oh, let me hear Michael talk. No, I'm going to do some teaching, but you're going to hold yourself accountable and to the rest of the class, whether you can get close. Now, I don't expect you to get all the right answers, right? Even if you get it wrong, I won't be disappointed. Don't worry. This will all make sense. I'm writing an article, so you will know. But what I want to do is I want to make sure you guys stay engaged and you turn on your brain so that you are more in the active mode where you can retain information a lot more than just listening. Okay, so that's what you need to do. Let me remind you how some of the data structure works. Right? So data structure is basically, you just need to know two things, and it's just using the combination of those two core building blocks. You can create any data structures. It's basically just functions and OOP. That's all data structures are, right? You're using functions, sometimes recursions, and you're creating OOP objects, and you're just linking them each other, and that's basically all the data structures. So let me introduce some of the common data structure. So singly linked list is when I have a node, and it can have a value. It can be a number, it can be a string. You can store whatever you want into this bucket. So in this case, let's say that I have a number, 15, and I have, for example, a head point to the first node, and then the first node's next points to the next node that has certain value. And I can just keep adding things. Okay, that's a singly linked list. Right, so I just keep adding things to this list. It's almost like a train that has one-way connection, from one part of the train to the next part of the train. That's a singly linked list. Doubly linked list is basically the same thing, where I can have the head point to the first value in the node, let's say 15, but instead of one hook, it has two hooks. It has double hooks, right? So I can say next points to that one. And then this one, it has a hook called previous, and this one has a next that points to another value and so forth. So basically it just has two hooks. So instead of one train sending a hook to the next train, the one train has two hooks, one to send to the front, one to send to the back, right? That's a doubly linked list. Stacks and queues, don't worry about that right now. It's basically just a singly linked list or doubly linked list. Just treat it the same. Okay, so this is one bucket. So for this one, answer this. What order of operation is search? How many computations do you need to do to find a specific value in a linked list? So imagine, this was n size. How many comparisons do you need to do to find a value in this singly linked list? Okay, so put that order of n. Okay, once you found the node that you wanted to let's say now what you need to do is you need to insert a certain value somewhere in the node. Okay, either at the end of the linked list or somewhere in the middle. Okay, so if you want to do once you search and found the node that you want to insert, how many operations does it take for you to insert a value? So put that over here. Okay, and then what about deletion? Once you identify the node that you wanted to delete, what orders of operation is that? Okay? Write down your answers now on a piece of paper. Okay, let's go to the next one. Let's do arrays. Arrays is a data structure where it's basically compartments with index 0, index 1, index 2, index 3, 4, 5, 5. Okay, you guys all know how arrays work. So if I want to search a certain value in the array, what orders of operation is that? If I want to insert a value in the array, What orders of operation is that? Once I search and found the value that I want to insert, right? So insert is once you searched and found the index that you want to insert at, how many operations does it take for the arrays to change to the final format? Okay, deletion. Same thing. What's the order of operations there? Okay, pause and write it down on a piece of paper. Don't put in the comments yet. Just write it down, because what I want you guys to do is I want you guys to tell me 12 answers. When I say, okay, now submit your answer, I want you to submit 12 answers at once. So don't submit your answers right now yet. I appreciate you, staying active, but just write down that, your answers on a piece of paper. Don't submit yet. So that's arrays. Okay, so we did arrays, we did singly linked list, and there is a binary search tree. The way that binary search tree works is, let's say I want to create a list to organize a bunch of numbers. So let's say the first number is 5, so I put it here. Let's say the next number is 3. Well, I travel starting from the top, and if the number that I want to insert is less, then I look to the left. Well, I look to the left and there's nothing there, so I add it. Okay? Let's say the next number I want to add is 7. So I go to the top. Oh, 7 is greater than 5. So I'm going to look at the right. Oh, right is empty. So let me add 7 here. Let me say the next number I want to add is 4. Then I start from the 5. Okay, well, 4 is less than 5. So I need to look to the left. Oh, it's already occupied 3. But 4 is greater than 3. Let me look to the right. Oh, 4 is empty. The right spot is empty. So let me add 4 here. So that's a binary search tree. So now on a binary search tree, how long does it take to do a search? How long does it take to search the binary search tree looking for a specific value? What order is that? How about inserting a new value into the binary search tree? What order is that? What about deleting? What order is that? Yes, assume shifting. Okay, look for the average. Don't do the worst case scenario. Look for the average. Good question. Science of life. I like that. Okay. All right. So write that down for a BST. And even if you don't know, just make a guess. Don't worry. One thing I like about YouTube Live is I don't think it actually shows any of your comments. So even if your answers are wrong, no one's gonna know, right? You guys are safe. On the other hand, if I do Facebook Live, all your comments get to be shown in its capture. So I actually like the YouTube Live because you guys are protected. You don't. I'm the only one who looks bad, right? If I screw up, and there will be a permanent record of me screwing up. I don't care. We all make mistakes, but you guys can feel safe that your comments don't show up. So you can just give wrong answers as long as you guys will learn, and you will learn in a few days. That's okay. Okay. So BST. What's hash table? What is a hash table? Well, hash table is really, really simple, right? Imagine I have tons of different people. So I think about the analogy. Let's say I got 10 million people. Well, if 10 million people lined up like this, it would take forever to find, someone specific, right? If I'm looking for someone named Michael, do I start here and then go all the way 10 million times? Right? That's a long thing, right? So hash table, it basically says, you know what? We're going to do something cool. What are we going to do is everyone line up. You're going to talk to this group of people. Okay, hold on. And you go talk to them. And they're going to tell you which village to go. Which village to go. And there are 10,000 villages. 10,000 villages. So these guys basically said, person A, based on blah, 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 based on this logic, you're going to go to village number 1. You're going to go to village number 2. You're going to go to village 87 or whatever. So they came up with this logic. This is called a hash function. And based on the output of this hash function, they send these 10 million people across 10,000 villagers. So let's say you come in and you're like, oh, I'm looking for Michael Choi. Instead of, the previous way, you just talk to these guys and say, oh, based on our hash function, Michael Choi is going to be in village 9 9,865. So you go to village 9,865 and then you do a search, right? So you're saving a lot of time. So these are called buckets or rooms, right? It's just a way, it's a neat way to organize lots of data. You can also use this to create a hash or a dictionary. That's only if there's like one person in each village. But what's the fun in that, right? You can also have a singly linked list stored here, or you can have an array stored here, or you can even have a binary search tree stored here to organize the data even further. So you can kind of think of, hash table, right? Just think of the village example. Okay, I'm going to create 10,000 villages. I'm going to have a hash function that determines, where the value should go, which, villages should go, and then they can just look up there. Right? Okay, so that's what a hash table is in a nutshell. Very easy, right? Force our brain to think it's very easy. Okay, all right. So now, hash table, what's the search? If you're looking for a specific value, what orders of operation is that? Okay, if you're looking to add, once you found the value, if you want to insert something, what's the order of operation? Okay, now orders of operation of all of this is going to depend on whether the hash table stores a singly linked list or doubly linked list or queues or stacks, or if it stores an array. So what I want you guys to do based on that is, let's go back to this. So I misled you guys. I apologize. So what I really need you to do is, search operation, insert operation, delete operation. One is an array. Another one is a singly linked list, doubly linked list, stacks, queues. They're all the same. So that's 1, 2. 3 is a binary search tree. 4 is a hash table with singly linked list. 5th one is a hash table with arrays. Tell me sorry that these are kind of screwed up. And for each of these, what is the order of operation? 15 answers. And if you really just sat down and thought about how I explained it, you will be able to get all of these answers. But I don't want you guys to spend too much time. So just write down, to the best of your knowledge, just open up a text editor, right? And say for array, order of n, order of n, order of n squared, whatever you think. Singly linked list, orders of blah, 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 BST. 15 answers is what I want. I'm going to give you guys 5 minutes. Write down the answers. As soon as you're ready, go ahead and put down your answer. And I'm going to answer some of the questions. So efficiency is not just by the least number of lines, it's really the number of computations. So each if statement, just think of that as a computation. Start putting the answer. And I'm not gonna have time to check every single one. So even if you get it wrong, I don't care. I just want you to write something down, right? And remember, and then when I show you the answer, if it was different, then you will learn more, right? But if I didn't have you do this, and then I showed you the answer, you're gonna be like, okay, cool, I didn't, and it's not gonna sink in. It's much better for you to do it, and then for me to show you what the answer is. Don't do any Googling, guys. You're not gonna Google answers when you do technical interviews. You just gonna, right? So, and all of this will make sense when you do it too. When things are slow, I'm putting you on the spot. This is okay. Just come up with your best guess. It's fine. Okay, I like how Angel typed her answer. Everyone try to copy her example so that with just one comment has all the answers. Okay, so Angel, thank you for doing that. Yeah, I love how these answers are coming. And again, I have no idea if they're all right, but it looks kind of right. It seems like you guys are getting it. That's good. Good for you guys. Good for you. Good for you. Now, if you have no idea what I'm talking about, don't worry. Just do the modules at Hacker Hero and all this will make sense. But you can imagine if you walk into the interview without having thought about big O notation, you're like, okay, and they ask you, do a doubly linked list or do a binary search tree. And you're like, what is a binary search tree? Right? You started off at the wrong foot. You probably really won't get the job, right? So it's still helpful to speak the same language, even though you may never use a hash table ever in your life. I never used a hash table ever in my development life, ever. I never used a binary search tree ever in my life. I never used a singly linked list ever in my life, right? But it's still, it's good to know these things. And I mean, if I created a whole new language from scratch, I'm sure I'll use these data structures. If I created a new database from scratch, I'm sure I would have used it. But now, like, I'm not creating a database from scratch. Why would I do that? Am I creating a new language from scratch? There are already too many languages out there that's confusing anyway, right? Why add one, right? So, yeah, like, let's just do it for fun. I mean, it's really not that practical, except when it comes to interviews and impressing the hiring managers. But I mean, the big takeaway of these data structures is not really like you should be expert. Is to really understand how these building blocks work to optimize certain operation. Then it's training your mind so that even though in the real world you may not go and do bench press, right? Still, the art of doing bench press strengthen your programming muscle, right? So anyway, you got to have that perspective when you do data structure. Even though you don't know how to do any of these, it doesn't mean you're a bad programmer. I mean, it's all self-taught developer. Do you think they go and study binary search tree for a year? No way. Like, that's not practical. But okay, anyway, I probably shouldn't speak too much because I have some strong opinions about how things should be interviewed. But anyway, okay. I get a lot of answers in. Go in and submit it. And I'm going to show you the article that I'm writing. Alright, so the article I'm writing in Medium, blah, 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 array, okay, linked list, blah, 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 binary search, blah, 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 hash table, blah, blah, blah. Okay, summary table. This is what it is. Take a look. Take a look. And what did you learn by doing this exercise? Array is order of n, right? The important thing is what searching is order of n. Once you search, and then if you want to insert, that's another order of n. So if you're searching and then inserting, it's O(n) times O(n), which is O of n squared, right? So you got to remember that, right? If we're searching and then deleting the array, then that's order of n times order of n, so that is order of n squared. Stacks, queue, singly linked list, doubly linked, searching it is O(n), but once you identify the node, inserting and deleting is order of 1. Hash table, search, well, this is a little tricky, so let me skip that. But hash table with array is order of n, but divided by the number of buckets, right? So it's still more efficient than just doing it in the array, but so I intentionally put divided by buckets. You may not actually want to state that in the interview. Just know that this is still bucket times faster, number of the bucket times faster than doing it this way, right? If I have a hash table with singly linked list, doubly linked list, same thing. It's order of n, but still is faster than putting everything in a single stack queues or singly linked list or doubly linked list by the factor of the number of buckets. So if I have 100 buckets, it's still 100 times faster, right? So that's important to remember, okay? And then the insertion is O1, O1, because you're leveraging the power of the singly linked list or doubly linked list because my hash table has singly linked list there. If I have hash table with array, then it's not order of n, it's order of n divided by buckets for inserting or deletion. Binary search tree, all the operations are order of log n. Okay? Alright. So if you are like, what is going on? Why is that, or why is the answer blah blah blah? That means, okay, there is a gap. That's an opportunity for you to learn and go a little deeper. The color code means, green is good, super green is really awesome, yellow is not so good. So you can just kind of more easily see that, oh, arrays are crap, for large n. Okay, oh, stacks, search is kind of crap. But once we find it, inserting and deletion, oh, amazing, order of n. Oh, hash table, well, it depends on whether I'm storing an array or a singly linked list or whatever. But if I'm doing singly linked list, I kind of get the benefit. The search speed improves significantly, and I still get the insertion and deletion at orders of 1, which is good. Binary search tree, oh my goodness, search is so much faster than any. Well, not anything, because hash table, yeah, but there's a rare case. But searching is really, really good for a binary search tree. Insertion, it's not bad. Deletion, it's not as bad. But it's not as good as the linked list. But what we do save is we save a lot of time on the searching, right? So if I'm searching and inserting something on the stacks, what would that be? That's still n, order of n times order of 1, which is order of n, right? If I'm doing a binary search tree, searching and inserting, that's log n times log n, which is faster? Log n twice or order of n, right? Log n is still faster, right? So don't look down on binary search tree because you're like, oh, insertion and deletion is log n when stacks and queues are order of n. A lot of times, do you just insert and delete? No, you have to search and then insert and delete, right? So you can see that because this is really, really good on the binary search tree, the search. So, I mean, it's a very efficient way of inserting, deleting, searching information all the way around, okay? All right, so yeah, that's a good point. Yeah, there are pros and cons, right? Hash table uses a lot of rooms. It's like the 10 million example. I had to create 10 million villages or 10,000 villages. That takes up a lot of space. And then, I have to do this hash computation tool. So imagine when I initially organized 10 million villagers to 10,000 villages, every single one had to talk to my hash function and I had to compute that, right? So there is trade-off. There is trade-off for sure, right? And you got to understand the trade-off. Now, there are variations of the binary search tree, and I sometimes get really frustrated when there's so many names to memorize. Why are people coming up with all these new names? Okay, so it's a binary search tree that's balanced and you gave that a name? And then it's another binary search tree that it has a slight and you give that a name? So now I have 30 different data structures for me to remember? Forget it, right? I'm just going to remember binary search tree, right? And if interviewer is like, really hard on me for not understanding some of the names, I'll be like, why don't you explain to me, what that means? And, I can still answer your question, right? So anyway, I have some strong opinions about how interviewing should be done, and it's just some of the practices that are being done right now. It's like, they're interviewing people for what used to be relevant back in the web one, not even in the web 1.0, back in the early days, like of the DOS, and they're still using that to interview people now. It's like, come on. But anyway, okay, gotta be positive. The positive attitude is, okay, yes, we may never use any of these structures ever in our development career other than interviewing, but still it's gonna strengthen our muscle and help us to become more analytical, okay? Okay, so we gotta be positive. We shouldn't be negative about the world. But I do have some negative feelings that I'm trying to work out. Okay, tries and graphs, they're all simple. They're all simple things, tries and graphs. I mean, all of these are, it's like, I can't believe they just come up with all these names. Like, tries and graphs are simple. Like, it's just nodes connected in different ways. That's graphs. Tries is connected like 3 different ways, or like, just look it up. I mean, if you connect the node certain way, they call it tries. They connect a certain way, it's called graphs, right? I mean, it's really not that hard. But I mean, one example of, I mean, there are many examples. For example, let's say I'm doing genealogy work, and this is me, and these are my parents. Okay, so I'm their kid, and these are my siblings, and then they have parents, and blah blah blah. Right? You can imagine. Oh, it's just each of them is an object, and then I have some rules to indicate whether they're children or siblings or blah blah blah. Okay, all these examples where I have a bunch of nodes connected by some logics are called graphs. That's it, right? Let's imagine an example of a map. Imagine that there are certain destinations like this, and then there are certain highways like built roads that are connected like this, and you want to find the shortest path from one node to another node, right? And that's like Google Maps, right? Google Maps is just a bunch of locations. You can see from the street, which node is connected to what, and then you can compute, oh, this is the shortest path, blah, 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 right? All of these are just examples of graphs, right? Tries, I actually forget what tries are. Try is, oh, okay, so yeah, it's like that. Okay, so tries is like, okay, let me have a word A, and then I want to put another word, that starts from A, and maybe it starts, the next word is T, so let me connect it that way. Oh, I have another word that starts with A. Oh, keep adding things to the list. AC, okay, good. And then, the list can just go on and off. That's called try, right? All these data structure is basically just nodes that are connected with certain rules, right? And then you use recursions, usually, to navigate through these nodes. And that's all it is, right? And they give it a different name. So whenever you feel overwhelmed with all these data structure, like, in order to prepare this, I was doing some research to see all the different data structures, all the different variations of binary search tree. There were like 10 different names for it. Yeah, try not to get overwhelmed. Everything boils down to just simple objects and how things are connected. All right. Yeah, they do ask graph questions. So genealogy graph, remember it, okay. Red black tree. Yeah, I've read that. And all these names are just so confusing. Why do you call? I mean, you might as well just, yeah. And you can just come up with your own way that node is connected and give it a new name, and then go in and post it on Wikipedia. And then another one thing that people need to remember. Okay, I gotta try to be calm. Okay, it's okay. I again have some strong opinions about how recruiting should be done, and I'm frustrated about the process, which is why I started another company, which is to help people find jobs more effectively instead of the current system. Okay, so I think I'll kind of leave it at this. Okay, give me some feedback, guys. I'll share this link. How helpful was this exercise? Did you learn something through this exercise? Were these things that you already knew from either going through the boot camp or from your current experience? Give me some feedback. Are there things that I should add to this to make it more relevant for you guys or for other dojo graduates or other people who are getting ready for interviews? Go ahead and post that comment here now so that I can after the session I can take a look at it and I can do some revisions on this article before I post it. Okay? All right, so now I think because it is already 6:50 and I kind of went on and on and on, I don't know if we're going to do system design. So what I do want you guys to do is I do want you guys to watch all the videos. Okay, don't go to the next challenge. Let's do the on the system design. The next one is we're gonna be designing another one. So just go up to challenge 1 and watch all the videos and go ahead and spend time on the advanced algorithms and try to do as much of this as possible. Okay? All right, so I think we'll end the lecture or end the live class like this because I talked too much. I'm sorry that I didn't manage the time, but tomorrow we're gonna go back to system design and talk about how to architect an application that's way more complex than the one that we did yesterday. Okay. And again, I think on Friday we'll still talk about some OOP design patterns, and we'll talk about that. So I think that will be good. So we have tomorrow and Thursday to do some system design. So be ready. I think tomorrow maybe go a little bit longer. Maybe Thursday will go a little bit longer because I want you guys to design the database too, and I want to give feedback on the database too because I think that will be meaningful. So today's was a little bit shorter, but tomorrow and Thursday I think will be a little bit longer. Okay, sounds good. So I'll stay here for another 5 minutes or 10 minutes, depending on how many questions you have. But still, do every one of you, please do leave me a comment on how helpful that exercise was, or seeing this table. And if it was, I'll keep it. If you feel like okay, it's missing X, Y, and Z, let me know so I can make this better. Okay, all right. Well, it's good to have you guys. And we did have quite a bit of people, so we may just do Google Live, YouTube Live. If we don't have that many people, maybe we'll do Zoom. But let's just plan on doing YouTube Live for now. Okay, so you guys can log off. Thank you. Talk to you guys later. Oh, Scott, so you do have a good point. Yeah, maybe. Okay, I have to think about that. So yeah, you do a search and then you're shifting. So it may be, you may be right. Maybe it is not, it is not O to the n square. It would be O(n). Okay, let me think about that a little bit. You may have a good point. I think you bring a very good point there. So we know it is, it takes more time than just order of n, right? But if I do a search, I identify which takes O of n, and then I do an insertion, it's another order of n. So I think, yeah, it's not inside the search that I'm doing a shifting every time. So I think, I was thinking about some of the sorting algorithm when you do the search and then you're shifting things, right? Which is why it's times. I think, for these operation is plus, right? Because so anyway, I think I got mixed up on some of the sorting, right? Because you're again doing searching and then you're shifting every time you do a search and you're mixing things, which is why order of n to the square. So I think, Scott, you're right. Good point. That it would be order of 2n or another order of n, right? Yeah, good point. Very good point. Thanks for bringing that up. Space complicity depend on input size? Yeah, it does. It does. You know, some of the space, the memory or the disk space, yeah, it's usually. I mean, if it is order of 1, then it won't depend on the input size. But a lot of it will depend on the size of the input. So that's a good question, DS. Yeah. So, Tino, Java, we're not done. Java is not, it's not working. So maybe you try in Python or JavaScript. We we ran out of time on translating the questions into Java. So we translated some of it, but some are still in the works. So yeah, sorry that it's not working on Java yet. We just didn't have enough time to translate all of it properly. So maybe you can just again use JavaScript or Python. Sorry about that. Yeah, it's confusing. You know, these order of operation can get so confusing. And I mean, it's just not possible to remember all of these. I had to sit back and be like, okay, hold on. What's happening in the singly linked list? And I have to do it one by one. Right? I'm like, oh yeah, okay, so that's order of n. Oh, and then right? It's hard. Yeah. Okay. Sounds good. Yeah, it's good to have you guys. And you know, thanks for these thoughtful comments and questions. You know, Scott, I'm glad you caught that. Very proud of you for catching that. Very, very good. Yeah. Okay, so I think we will end this. For the 14 of us who are here, you guys have a good night. Okay, we'll see you guys tomorrow. Okay, bye-bye.